Good morning. Shall we start? Okay. Good morning, everyone. So today is the last day, and we have to do several projects today also. We shall start with AC drive project. Then we shall go for analog ADC DAC programming. And afternoon, we shall go with one small project of IoT, where I would request overseas participants to operate machine from their place. I shall arrange IoT system here, will connect to PLC, and any overseas person can operate it. So overseas participants, kindly you text me to my number. Although we shall do this after lunch. I want you people to understand the use of variable address. Percentage MW1, you remember that we have used in codices. Percentage MW1. When we made program, percentage MW1 we have taken, but we did not start from MW0. I had told don't take MW0. Why have why have we not used MW0? That I shall tell you today. Variable address programming is very interesting. You will see if you understand variable address, you can make your program without using output coils. You can make your program without output coils. Like yet we have used Q0, Q1, Q2 in coils, and outputs are on respective terminals are high. But we can make program where we won't have any output coil, But our output addresses will be accessed, our output terminals will be accessed. How can we do that? Let me tell you. And then we shall come to AC drive programming, and we'll run one project, multi-speed control of induction motor using AC drive and PLC. Okay. First, you see this. Here, I take percentage MW1. What does it mean? And we have used percentage. Just a minute. First, let me tell you about percentage mx 0.0. What is this? This percentage is just one syntax. What is this m? M is actually flag, correct? M is flag. If it is qx 0.0, q is output. Then we have x. What is this x? X is actually bit. Bit or bool also you can say, BWL, bit. So X denotes bit here. In this address, X denotes bit. What is this 0? This is actually word address or location, you say, not address. Word location. And what is this 0? This is bit location. You can write down if you want. Bit location. So when you have one address, it has some meaning. So M is for flag, X is for bit, 0 is, this 0 is word location, and this 0 is bit location. Like that, you have here percentage MW0. What does it mean? Again, this M is flag, this W is word, and this Z is word location. Word location. So word location we have. Note down please. So percentage mx 0.0, you understand what do we have inside it, and mw0, what do we have inside it. Now we have relation between this address and this address. How? I shall tell you. Okay, I shall remove this now. You can take a screenshot. I shall remove. Okay. Now you see. Now you see. You understand bit, right? You understand bit. Answer me. When I combine 4 bit, what will it create? 4 bit is equal to 4
Sir,
bits
one
will
nibble.
be equal to
One
1 nibble.
nibble.
It would be very good. 1 nibble. Yeah. When we combine 8 bits, then it would be, what is this? 8
One
bits
KB.
equal to
One byte.
1 byte. Yeah. 1 byte. Okay. And when we combine 16 bits, then it would be 1 word. And when you combine 32 bits, then it would be 1 double word, 1 D word. So all these things will matter in your program. So this is your relation of bit. This is the combination of bit. So 4 bit, 8 bit, 16 bit, 32 bits. Now you see this percentage MW0 is a word address, isn't it? It is a word address. What does it mean? One word will have 16 bits inside it. Okay, let me remove this and we'll show you. You know that addresses or memory will be generally in 16 bits form. Somewhere it is 8-bit forms also. So in simple, I shall tell you, on data memory, I told the memory location where all addresses are allocated. Data memory
Why do
is
you
the
hang up
memory
my
location. Did you ask anything? Mute, mute, please, everyone. Yes. So, all our addresses on data location, data memory, will be in form of word. Now, we have some area allocated, like some area is for inputs. All inputs will be there. Some area will be for output. All outputs will be there. Some area will be for flag. All flags will be there. So you can say, okay, you consider that some question. Stream has not started yet. Is it so? Check, please.
Yes, sir. It's not being telecast.
Okay, then then you start it first. Coordinator, you start and tell me. I shall start after that.
Sir, it works in 16-bit operation, no?
What?
Sir, for example, we have some processor like 8085 or ARM processor in which word is in ARM processor is of 32-bit and in 8085 it's 16 bits. So it depends upon the processor which is acting, no?
It depends.
So
Like
it's a
if it is 8 bit, then it will be in form of 8 bits. All addresses. 16 bits will be in 16 bit, like 16 bit. One word actually will be in 16-bit location. If you have 32-bit, then also it would be in word location only, but two words will be used for that. Coordinators.
So the YouTube link has been changed due to some issues. We can't live stream in that.
Did you share it, please?
Yes, sir. It's shared in WhatsApp group.
Okay, fine. Then I shall start. Okay, participants on YouTube, is it okay now?
Sir, we have joined with Google Meet link.
No, I'm asking to the participants who are on YouTube. They will text me in WhatsApp if they are listening to me. Now, okay. Fine. Okay, very good. So, we'll start from beginning again. So just now we had discussion that if we have some addresses like percentage MW1 or percentage MX, very first I shall tell you about MX. If we have one address percentage MX 0.0 or IX 0.0, QX 0.0, what does it mean? For MX 0.0, M is flag. For X, what is this X? This is bool or bit. This is bit. What is this 0? This is word location. Word location. You manage, you can write down full name. Word location. This is bit location. This is bit location. So this is the meaning of address. Now if we go, like if you have worked on Siemens, then it would be uh, MX 0.0. MX is not there, right? M M 0.0. So in Siemens, if you have seen M 0.0, there also M is flag, 0 is the word location, and there it would be bit location because they give in uh, 8-bit format they have addressing. So bit location and byte location and bit location, not word location, but byte location and word location. Okay, fine, let it be. Now you see this. This is percentage M. This is MW0. Here M is again for flag, W is for word, and this 0 is for word location. Word location. Okay. So flag, word and word location. So this is the meaning of address. After that, I told that when you combine 4 bits together, it would be one nibble. When you combine 8 bits, it would be one byte. When you combine 16 bits, it would be one word. And when you combine 32 bits, it would be a double word. Now, after that, I told that all our addresses, like we have input address, output address, flag address, and other addresses, all addresses will have its own location on memory. You can say, just consider we have some colony for some community. So in input community will have one colony, output community one colony, flag community one colony, and that colony will be very much managed. You see, how will it be? If you have suppose flag location, you have flag location. Your flag location will be in form of 16 bits. It will be in form of 16 bits. One word actually. One word is will have 16 bits. So bit 0, 1, 2, 3, like that. So you will have bit 0 to bit 15, bit 0 to bit 15. Wait, I'll show you here. Now you see, this is your zero location, correct? Zero number word location. This is your one number word location, two number word location. And as it is for flag, this lane you can say this is one lane, and in lane you have some houses. So lane is your word and house is your bit. Consider this lane, this road is your word and houses are bit. So this road number will be, road address will be percentage M W0. What does it mean? This road is actually for flag word 0 number road. Now, what would be the house address? What would be the house address? What would be the house address? You see here. House address would be, concentrate, house address. This is the house of flag only because it is flag location, right? So this is for flag. So very first it would be percentage M because it is for flag. Now this is a bit, right? No, 1, 0, 1, 2, 3, 4, 0 to 15 bits. 16 bits will be 0 to 15. So this is your 0 number bit location, 1 number bit location, 2 number bit location, 3 number bit location. Like that it will go to 15 number. So this house would be percentage M X. X means what? X means bit. X means bit here. MX. What is the word location? This word location is 0 number. And what is the bit location? Bit location is also 0 number. Here you see, what would be the address of this location? This will be percentage M X word number 0 and bit number 2. So MX 0.2. Got it? Here you see, this is MW1. This is MW2, like that. So when we talk about percentage MW1, it means it has, listen, try to understand, MW has flag, combination of flags. MW0 has combination of 16 flags from percentage MX 0.02 percentage MX 0.15. Got this? So here also percentage MW1, we have combination of flags from percentage MX 1.0. Here it would be 1.0. Its flag will be percentage MX 1.0, 1.2, 1.3, like that. Here it would be 2.0, 2.1, 2.3, like that. So this MW1 word will contain percentage MX 1.0 to percentage MX 1.15. I hope you understand. So one word is a combination of flags. One word is a combination of flags. So do not, sorry, do not use, like in your program, if you have used percentage m x 0.0, then in your program you should not have percentage mw0. So you should not use this series of word. You see, this word location 0, already it's a bit you have used. So if you are using a bit, don't use its word. If you use its word, don't use its bit. That's why in our program we have used percentage mx 0.0. So I had told don't use percentage mw0, or else what will happen? What will happen? You see, what will happen if you have used m 0.0 in your program and you use percentage m w0 also in your program. You had taken time to word, so it was getting 1 2 3 4, some numerical value it was getting. So as it will get the value 1, decimal value 1, what will happen, you know? What is the binary of 1? Tell me. What is the binary of 1? What is binary of 1? Decimal value 1. 1. Yes. Okay. See here. Binary of 1 will be 0 1, correct? 0 1. So you see, try to understand. If your timer is running, as timer finishes 1 second, percentage mw0 will get 1. As percentage mw0 will get decimal value 1, on this location what will happen? Binary of 1 will be 0 1, so this bit will be on automatically. So flag this flag will be on automatically. If you switch on or you don't switch on, this flag will be on itself. Now you see what will happen. If this mw0 gets value 2, what is the binary of 2? It is 1 0. So what will happen? This flag will be off automatically. This flag will be off automatically. So as your latch flag will be off, everything will be off at the same time. So as you press start button, you remember the timer program. I0, Q0 on for 10 seconds. So you press I0, you take M0 latch. From M0, you are running output Q0. From M0, you are taking a timer, and that timer visualization you have taken percentage MW0, suppose, time to word, MW0. So as timer will start, as it will finish 2 seconds, as 2 will come in percentage MW0, 1 0, it means M1 flag will be high and M0 flag will be off itself, and you will be wondering, oh, what's going on in my program, why the coils are getting on off itself, I'm not operating it. So this is the effect of word on bit. So if you are using a bit, don't use its word. If you use word, don't use its bit. That is it. Okay. One thing I had told that I shall show you, we can make program without output also, output coil also. How, you see? Suppose you have to get Q0, Q3, and Q2 on. You have to get, when you press I0, you have to get Q0, Q2, and Q3 on. So how can I do this? I shall use I0 start, like consider it is push button or toggle, no problem. I shall use one instruction move, MOVE. And what shall I do? I will have to calculate, like this is Q0, this is Q1, this is Q2, and this is Q3. And this location is percentage QW0. Now you see 1, 2, 4, 8. Tell me, when you get Q3, Q2, and Q0 on, your binary will be 1, 1, 1, 0, 1. What is the decimal of 1, 1, 0, 1? So it would be 8 plus 4 plus 1, 13. So I shall move 1, 3 to percentage MW0, sorry, QW actually, QW0, or I can move to percentage QB0 also, QB0 also. So only this ladder will make your these three outputs on. You see, I don't have any output coil, but these output addresses will be high and connected output will get on my machine. So you can see by moving decimal value to word location or byte location, we can operate our output without coil. Output without coil. So this is a complete program. Okay, let it be. Now I cannot give more time to this because today, first half, we have to finish two things: AC drive program and analog program. So I shall move. Actually, this I told you because in analog program we shall have discussion about this. Fine. Now I come to the portion AC drive. As I told, we shall do one project today. The project will be multi-speed control of induction motor using AC drive, and command we will give from PLC. So what happens actually in industry, more and more motors will be used. So motor will be the main output in industry. Number of motor will be more there. So power is also consumed more by motor in industry. So electricity will come mostly because of motor in industry, because more and more motors you will find there. When you see any application in industry, generally a normal motor in India will run on 50 hertz. Outside we have 60 hertz. So when you run a motor on 50 hertz, it is consuming maximum power. But most of time you will see, like when you have conveyor and all, you have not to operate the load on that frequency, on that speed, you can say. So you have to run your conveyor on low speed, but you will find that motor has been running on high speed. And using some gear, we reduce the speed of load, speed of conveyor, you can say. So most of time you will see the motor has been running on maximum speed, it is consuming maximum power, but your load has been moving at low speed. So in that case, it is wastage of energy, isn't it? It is a lot wastage of energy. So we don't require that much energy in terms of load, but our motor we have been running on high speed. So there, please mute everyone. Please mute your mic. So in that case, you have seen, you have used gear motor, we use some pulley or we use some friction, and we reduce the speed of load. So initially we had a lot wastage of energy. To eliminate that, drive came. Using drive, you can control frequency of your motor. You can control frequency of your motor. And if you have to run your conveyor on low speed, suppose I want the speed of suppose 20 hertz or 25 hertz or 30 hertz, you don't need to run your motor on 50 hertz. You can run your motor now on 30 hertz only. Conveyor will run on 30 hertz. If you have to run your if you want to run your conveyor on uh, 10 hertz, 25 hertz, 15 hertz, you can control the speed of motor, and you can save a lot energy and can save money also in your industry. So AC drive, VFD, variable frequency drive, we use to control the parameter of induction motor in industry, AC induction motor. For DC, we have DC drive also, and for servo, again we have servo AC drive, servo DC drive. Obviously, we have different types. We have different type of control also in VFD, like voltage control, current control, pulse width modulation control. In AC drive, see, I know that scholars and faculty in academics, they have more knowledge about its internal operation. In industry, we people just see its applications, but internal operation, power electronic people, they are very good in that. They know very well. But some idea means what is the working principle? What happens in AC drive? We have three parts: first part, second part, and third part. First part is you are going to provide a 230 volt AC, 440 volt AC. First, it will convert AC to DC, because DC can be controlled easily. AC to DC, it will be converted, but it won't be very much smooth. So some capacitor or some circuits will be used, and filter, you can say. So filter will be there. Filter will be there, and will be controlled by IGBT or MOSFET using high frequency switching. They control frequency, high switching, high frequency. This is the means you can say uh, your frequency will be proportional to high frequency switching. So MOSFET, IGBT, these devices will be electronic devices will have more frequency, will have very high frequency switching. So by using high frequency switching, the things are controlled, and lastly, it would be converted. It will be inverted, you can say. That's why we call it inverter also. Inverter. I think TER, right? Inverter. Or TOR. What is spelling inverter? Whatever, you see that. So AC to DC first will be converted, AC power into DC power. It will be filtered, and then it will be inverted and will be given to your motor, and motor frequency will be controlled. We shall come to its application, because I cannot, I honestly, I am not very good in its internal operation and all. I am not expert on that. Academic people are very good in this. I shall come to the application and will do one project today. But before that, let me show you what do we have on one AC drive. I shall share some document about AC drive because it has many things. I have that with me. I have all the things like type of control, and type of you see, when you have frequency, as per frequency uh, we can divide the AC drive in different type, like low frequency, medium frequency, high frequency. It is classified. So we have many things here to discuss, but we shall come to the application part. And this part I shall show you on screen here. Now, what do we have on AC drive in things. On any AC drive, you will have one display where you can monitor frequency, RPM, or whatever you require. Then you have one potentiometer or knob, you can say. Through this, you can set your value, whatever value you want, you can set. Some AC drive will have keypad also. Through keypad, you can set it. We'll have run key, we'll have stop key, we have reset key, different type of keys you will have. Now you see its power supply. Now you have power supply. This power supply you will have to check. AC drive, what we are going to use here is having power supply 230 volt AC single phase, right? 230 volt AC single phase. 230 volt AC. We have here power supply. So if your power supply is 230, then your output will also be 230 only, where you connect your motor. So this is your power supply of AC drive, and this is your output of AC drive, and here you see this is your RYB. Here only your motor will be connected. As I have shown, I have directly connected my motor to those three terminals. So here I can connect my motor directly. I can connect my motor directly here, three-phase motor, as I had told that always we use three-phase motor with AC drive. So what I told, if power supply is 230 volt AC, single phase, its output will be three-phase always, but 230 volt AC, not 440. So you will get 230 volt AC, three-phase. So your motor should also be like that. Now, if you have three-phase 440 power supply, input power, when you provide it power supply, when you get the AC drive on by 440, then its output will be three-phase 440 volt AC. So your motor will also be three-phase 440. Okay. Now, if your AC drive is of 1 HP, suppose 1 HP, then your motor should be of maximum 1 HP, not more than that. Below that, it is okay. So as per your motor capacity, you have to purchase your AC drive, 3 HP, 5 HP, 10 HP, whatever you have. According to that, you have to purchase your AC drive. As HP range will increase, your AC drive size will also increase. And when you will go to big industries, AC drive size you might have of Almira size also, very large. And this is because of its heat sink, as it is having many high frequency switching devices inside it. So heat is generated whenever you have switching, heat will be generated, and to sink that heat we have heat sink there. So aluminum heat sink will be there. So as size will increase, your aluminum heat sink will increase, it will be very large. So as per the capacity of motor, you have to purchase your AC drive. Now, these things you understand. We have display, we have one knob, and we have some keys, power supply, and this is your motor connection. Now, another thing what we have on that. What do we have on that? Another things, let me tell you. Another thing, on any AC drive, we have digital input, digital output terminals also. Be very clear. And these are the universal things we have in discussion. So we will have digital input, digital output. First, let me tell you what are these digital inputs. I shall tell you the universal terminals, means those you will find on any AC drive. Very first, you will have a common terminal. You will have forward direction terminal, reverse direction terminal, then RL, RM, and RH. RL, RM, RH terminal. If you have AC drive in your college, further you can check. It would be there. So you will have forward terminal, reverse terminal, RM, RL, RM, RH. Let me tell you, name can be different in different brand. So don't worry about that. So forward terminal, reverse, RL, RM, RH. Forward you understand. This is start terminal. Means if you have to run your motor, then either forward or reverse terminal should get high. Then it will run in, it will run. So forward or reverse, these two are start terminal. Okay. So either you run in forward or in reverse, you have to give it signal. Okay. These three RL, RM, RH. These three terminals are multi-speed terminal. Multi-speed terminal. Be very clear. This we will use today. So if you have to run your motor in multiple speeds by one setting itself, then you have to use these three terminals. By varying these three terminals, we can control multiple speed. In our AC drive, they have given 7 speeds. If you have 4 terminals, you can have 15 speed control also. In some AC drive, you will find 4 terminals also. Then 15 speeds, some will give you 8 speeds. So like that, it depends. So ours is 3 terminal, RL, RM, RH. We have 7 speed control. Fine. We will have some output, digital output terminal, not analog. Digital output terminal. Why do we use this? Digital output terminals we use to get feedback from AC drive. Like, suppose I want overload feedback. If it is overloaded, signal should come to PLC. Or when motor reaches to high speed, we want some signal. Or any condition, some conditions will be given in its user manual. Without user manual, you cannot work with AC drive. Like I have Mitsubishi 520, I had told you. If I have another series of Mitsubishi, its rule will change, setting will change. So it's not like if I have Mitsubishi, all series of Mitsubishi will have the same rule. No, they have different rule. Without user manual, we cannot do anything. Another thing, terminal property can be changed. Like I can change the property of the terminals. Like it is for forward, I want to change this. No, I don't want to use this terminal for forward. I want to use first terminal for reverse. Then I have setting. I can go and can do some setting. By default setting, I told you here. I have told you by default setting. But it can be changed also. So in user manual, you can see, you can change the terminal setting that you will have to see in user manual. And all these terminals are are for external control. Be very clear. One AC drive can control one motor without any external controller. So AC drive itself is a controller to control all parameter of motor. You don't need any external signal. But in industry, everything is controlled by PLC. So PLC will only send signal to AC drive to control the motor. That's why we have external control. So that also you need to set. You will have to go to user manual and will have to search control option. There you will find, okay, if you want internal control, do this thing. If you want external control, do this thing. If you want both control, internal, external, both, then do this thing. So these terminals will be active when you are in external control mode. Then it will accept signal from outside and will operate motor, will run motor. Okay. So digital input, digital output. AC drive will have analog input, analog output terminal 2. See this. AC drive can be used as analog input and analog output. I shall give you one example. Mostly, I have seen in college, mechanical people and instrumentation. You people have some application. I shall tell you about that. For that, this analog terminal will be required. On AC drive, we have analog terminals. First, let me tell you analog input AI, analog input terminal. Analog input terminal, you can have off, uh, you can say current type and voltage type, both terminals will be available. So it is your analog input terminal. There you will get both option. You want analog signal in terms of voltage or you want in terms of current, will have one common. If you have to take signal from outside, if you are taking analog signal in terms of voltage, we will have more discussion about analog after this AC drive. So if you want analog signal in terms of voltage, then this terminal and this terminal will be used. If you want analog signal in terms of current 4 to 20 milliamperes, then this and this will be used. So analog input terminal. Let me tell you, we have analog output terminals also. Analog output. There also you have, if you want analog output in terms of voltage you take, in terms of current you take, common terminal will be there. Let me tell you one application to related to these analog input, analog output terminal. So this is a complete application. You might have heard about one question in college. I have seen many times people ask me. The question will be, suppose we have a three-phase motor and I have to control its speed from AC drive. There is one temperature transmitter, like analog signal you can say, temperature sensor also you can say, temperature transmitter I call it. So we have application, you understand, we have one temperature transmitter, and temperature, from temperature transmitter we are taking signal in terms of 0 to 10 volt. We are taking analog signal from temperature transmitter 0 to 10 volt or 0 to 100 degrees Celsius, suppose. So as temperature will increase, that voltage 0 to 10 will increase. As temperature increases, fan speed increase, we have to increase fan speed. Once more, as temperature increases, increase the speed of fan. This is the application. As temperature increases, increase the speed of fan. So what shall we do? From temperature transmitter, we shall take one wire to voltage, another wire to common. So now it is giving us 0 to 10 volt variable signal, analog signal. And we have motor connected here, which will run your fan. You have connected your motor here. Suppose here is the RYB. And you have set that for 0 to 10 volt, output frequency should be 0 to 50 hertz. Output frequency should be 0 to 50 hertz. This setting you will have to do inside AC drive, either through its software or directly you go to the AC drive and using its keys you can do the setting. Okay, no? So this application can be done. When temperature increases, simply connect your temperature transmitter signal to analog input, connect your fan motor to AC drive, go to the settings and you set that when analog signal will be 0 to 10 volt, our output frequency should be 0 to 50 accordingly. So this is one application for analog input with AC drive. Another application I tell you, output. Here you see, analog output. Here, let me do, we have suppose one Control valve. Control valve, control valve will be solenoid valve is digital, 0 1, on off, 100% on, 100% off. Solenoid valve is digital, control valve is analog. It requires 0 to 10 volt to be operated. It has percentage open close. So 1%, 2%, 10%, 20%, 100%. So its percentage open close will depend on 0 to 10 volt. As per voltage, it will be open to that percentage. Now application is, as frequency increases, as motor frequency increases, control valve open percentage should increase. Very simple. So here again we will have to do setting that as frequency goes 0 to 50 hertz, output, analog output, we should have 0 to 10 volt. This application will be done. So analog input, analog output, both I told you. Okay, fine. Next. One, okay, now I come to the use of common uses of AC drive, or you can say the common control of a motor through AC drive. First control, very common control we take from this is frequency control, speed control. Speed control is frequency control. As frequency is controlled, its voltage will also be controlled. It's not like only frequency will be high low, but voltage will also be high low. See, you will say that, okay, I have to reduce the speed of motor. I shall take a gearbox. I won't use AC drive. But do you know, we have many applications where our motor should run on 75 hertz, it should run on 150 hertz, it should run on 200 hertz. So how will you increase that in that case? So there AC drive will be used. So for those special purpose operation, special motors will be designed which can run on more frequency, high frequency. Okay, so your AC drive can increase frequency also. Not only it's not like it will decrease only below 50, but it can increase also above 50. So as I told, 150, and yesterday I had told, no, what was the capacity I had made you know? I think 120 hertz this AC drive can control up to. So like that, you will have some motor which will go for 300 hertz, 400 hertz also. So for that, AC drive will be required. I hope you understand. Okay. Next, after speed control, it would be a direction control. We need to change the direction. We have conveyors where sometimes it will run in forward direction. Sometimes it should run in reverse direction. You people answer me. We don't have AC drive and all. Normal three-phase motor we have. We have to change the direction of three-phase motor. Generally, what we do to change the direction of three-phase motor? Tell me.
Change
What?
the terminals of the motor, sir.
Change the phase, correct? Change any two phase. To change any two phase, you can change. You have three terminals, three phases are there. So any two terminal you interchange, it will change the direction. But in industry, we cannot do all the time that we will go and will change the terminal. So it should be automatic. In that case, AC drive will control the direction also, forward direction, reverse direction. And I told we have here forward reverse terminal, or internally also it can do this. Then third, acceleration time control. Acceleration time control. Acceleration time control, what is this actually? When you start your motor and you have set 50 hertz, as you start, it will take some time to reach 250 hertz maximum speed, whatever you have set. That time we can set. If we want, okay, I press a start button, it should take 15 seconds to reach to final speed. So it will go in that ratio only. It will start and it will slowly, it will start, will increase, and in exact 15 seconds, it will be on high speed. If you give it 1 minute, then it will take 1 minute to reach maximum speed. I have given 1 second. So in 1 second only, it will reach to maximum speed. I have tried for zero point 0.5 also. In zero point 0.5, it goes to overload. So 1 second, I have seen it is okay. So 1 second, if I give 1 second, in 1 second, it will go to maximum speed, 50 hertz, or whatever you have set. If you have set 10 hertz, then 0 to 10 hertz, it will take 1 second to reach. So that setting also we can do. Acceleration time control, we can do. Okay, next. Deceleration time control. What you call deceleration? What you call actually? I have one confusion. Like I call deceleration. I have some issue to pronunciate it. What you call?
Retardation.
D?
Retardation, sir. Retardation.
Retard.
Retardation.
Okay, retardation. Okay, fine. So retardation time control we can have. The same. As you stop motor, it will take time to go to zero speed. Zero speed means its shaft will be chocked, will be bricked actually. So that time we can set, if we want 10 seconds. As you press stop, it will take 10 seconds, and in exact 10 seconds, it will stop your shaft. I have given 1 second. So in 1 second only, yesterday you saw the direction was changed. In video, you can see. So in 1 second, it will change its direction. In 1 second, it will stop, I can say. So acceleration time control, retardation time control, and multi-speed. Although we have many controls, when you go to its user manual, 200, 300 type of setting they have given. So we can control any parameter of motor using AC drive. But we have discussed about frequency control, direction control, acceleration, retardation, and now the important what we have to do one project on, that is multi-speed control. Let me tell you about that. Multi-speed control is a setting in AC drive. In multi-speed control, as I told, we have 7 speeds here. In AC drive, I think it will on my PDF also. See, these are the AC drives on your screen of different brand. So AC drive will look like this. Its size will increase. So this part you see, this part, this is your heat sink. Behind every AC drive, you will have big heat sink. So you can see you have display, you have some keys. Through this, we operate it. We do some settings. And when you remove this box, this cover, there you have terminals to give power supply, and terminal for motor, and those digital input output, analog input output terminals will be there. This is one application. We won't do this. We will do this one, but for that, first we need to understand multi-speed. Here you see. This one you see, this part. Now, as I told, we have forward terminal, we have reverse terminal, we have RL, RM, RH, and common terminal on AC drive digital input terminals. So if you have to run it in forward direction, then this signal should be high, reverse, RL, RM, RH. We have to discuss about RL, RM, RH. RL, RM, RH. By varying the combination of RL, RM, RH, you can change your 7 speeds. But the combination will depend on manufacturer. You don't need to remember it. Go to its user manual and find their multi-speed. It will take to you one chart, and there it will show you. Further, I will show you. I will download from internet and will show you, or it will be in my laptop. It's user manual. There they will show you using some graph and all. It will show you this speed, this input should be on. So here I have noted down. You can see here R, H, R, M, R, L. Here you see. So you can see for speed number 1, this is your speed 1. For speed number 1, RH should be on. Let me tell you, I have given here speed 50, 25, 10, 30, 40. It depends on us what we give. It's not like that first speed should be high speed. I can give it 5 hertz also. So it is not like RH is for high speed only. But in manual it will be written RH is for high speed, RM is for medium speed, RL is for low speed. But it's not like that. When RH is high, we have to give high speed only. No, we can give any speed, but this is for speed number 1, you can say. So when RH will be high, speed number 1 will run. When RM will be high, speed number 2. RL will be high, speed number 3. When RL, RM both will be high, then speed number 4. RL, RH both are on, speed number 5. RH, RM both are on, speed number 6. RM, RL, RH. All three are on, speed number 7 will be high. So you can understand by varying signal of these three terminals, we vary speed number. Now the question is, where shall we feed these frequency? See, it depends on us. I told you, we can decide it. Manufacturer will not decide it. This we shall decide. RL, RM, RH combination, manufacturer will decide. Now, where have we to set this? We have to set this in memory of AC drive. Memory of AC drive, we call it parameter of AC drive. Listen once more, parameter of AC drive. Now it is manufacturer decided that where have you to feed that. Again, you need to go to user manual, and in user manual they will give you, okay, if you want to give your multi-speed number 1, you go to, as per this manual, as per this AC drive manual, you will have to go to parameter number 4. You will have to go to parameter number 4, or you can say memory number 4 of AC drive. There you can feed 50 or whatever frequency you want. Parameter number 5 for speed 2, parameter number 6 for speed number 3. Then you see they have given 24, 25, 26, 27 number parameter. We can't say why not 7, 8, 9, 10. They have given, we have to use. We can't claim. So we have to see. They have given 4, 5, 6 for 3 speeds, then 24, 25, 26, 27 for other 4 speeds. So 7 speeds you can feed there. Now you see. After feeding multiple speed frequency, and you will do all the settings, or if you have connected with PLC, you will do program and all. You will press start button, and you can see you have set the time also. That speed number 1, 10 seconds, then next 8 seconds, 7, 5, 9, 6, 11, whatever you have fed. As you start, first speed will run for 10 seconds in your forward direction. It depends on us whether we want in forward or reverse. We have decided first speed forward, then reverse, forward, forward, reverse, reverse, forward. So all these settings we need to do, and we have to press a start button. It will run for those many 7 speeds. Like you go to milk industry or food industry, they have some sequence to stir the things, correct? To mix the things. So there they set multi-speed. Once they set multi-speed for the motor, 3-phase motor will be there. They will just press start, and as per program or as per the setting in AC drive, multiple speed will work. Okay. Now we come to the programming part. Let us do this project, multi-speed project. I told wiring is very simple, but what you do, 1 minute you take rest, or else it would be so complicated. After 1 minute, we shall have discussion about this project, and we'll tell you how we shall make it. Take rest, please, for 1 minute. Okay, 1 minute over. We shall resume. See this. Now let us make plan. First we shall make plan. Application you understood that when we press start button, motor should run in 50 hertz for 10 seconds. Got it? In forward direction. Then after 10 seconds, it should run in reverse direction and it should run for 25 hertz for 8 seconds. After 8 seconds, this is speed, then this is speed, this is speed, this is speed, this is speed. So 7 speeds we have decided. Direction also we have decided. Like direction you see here. Direction is here. Forward, reverse, forward, forward, reverse, reverse, forward. And RL, RH, RM also we have noted down from user manual. Now you come here. Here I can annotate and can tell you. So what we have decided, we shall use PLC output terminals to give signal to AC drive. So we have decided here that for forward direction, we shall use Q0. It means in our program, as Q0 is high, motor should run in forward direction. Got it? Got it? When Q0 in our program will get high, Q0 terminal will be high. As Q0 output terminal is high, signal will go to forward terminal of AC drive. So we have decided some output. For forward direction, we decided Q0. For reverse direction, we decided Q1. For RL, Q2. For RM, Q3. For RH, Q4. So this Q0, 1, 2, 3, 4, these are output terminals of PLC. And forward, reverse, RL, RM, RH, these are the terminals of AC drive. Clear? Is it clear up to this? Is it clear up to this that we have taken some outputs of PLC to give signal to AC drive terminals? Is it clear? Tell me.
Excuse me, sir.
Yes.
Sir, I'm still confused about this RHRM RL. I mean, are these are user defined or manufactured this way? The binary combination of RH, RM, RL, and R.
See, I shall tell you. Did you understand forward, reverse?
Yes, sir. So forward is user defined, right?
Yeah. See, this terminal, this terminal, this. These terminals are on AC drive. But its command we can decide. Like I have to run motor in forward or reverse, we can decide. So we have decided here, okay, first I shall run in forward, then I shall run in reverse, then forward, forward, reverse, reverse, and again in forward. But these terminals are given by manufacturer. We have not decided. These are decided by manufacturer. But command will be decided by us. RL, RM, RH terminal are also given by manufacturer. And these three terminals are for multi-speed control. Like if you have to run your motor in different 7 speeds, then you will have to give signal to these three terminals in its combination given in user manual. So these things you see, this setting is defined by manufacturer. This we have not decided. This is defined by manufacturer. This we have decided. This combination we have decided. This we have not decided. This is decided by us. Time we shall decide. Frequency we shall decide. But this setting we won't decide. So what I have cut will be decided by manufacturer, and what I have marked true, it is decided by us. Is it clear? Is it clear?
Yes, sir.
Anyone, if you have question, you can interrupt me in between also. Okay, done.
Sir,
Now
what
you
is
see.
this PR number?
That is parameter number. Parameter number, you can, in simple, if you say, these are the memory location of AC drive where you have to feed your frequency. Like I have 50 hertz. I will have to assign this 50 somewhere. No. So this 50 I shall assign in parameter number 4 in AC drive. Okay?
Okay, sir, understood.
Very good. So we have decided our output and setting also we have done. Like we have decided forward reverse. As per user manual, we have given combination for multi-speed RMRH. We have decided this will be our time, and these are the frequency. Okay, done. So you see, this you have to set in AC drive. This you have to set in AC drive to PR number. And other things we will do from program. These all we shall do from program. So you can see we have decided Q0 to Q4 to get this from AC drive. Okay, let it be. Now you see, sorry, from PLC. Now you see. How shall we make program for this? I have already made its program. You see here how I have made it. First of all, I have made program for these timers. See here. First of all, I made program for these timers without output. You remember traffic light program, 3 output program, or yesterday we made 5 output program. So you have seen one output timer, one output timer, one output timer, correct? And timer done bit was taking the things forward. So first timer was running second timer was running third timer was running fourth timer, correct? No? Like that, first of all, without using output, I have made program only for timers. Let me show you. See here, it's not difficult. You can see X0, M0 latch. So it is your start circuit. X1 is for stop, so breaking latch. Now you see X0, M0 latch from M0 first timer, T0K50. Then this timer done bit, first timer done bit will run second timer done bit running third timer, third is running fourth is running fifth is running sixth, and sixth is running seventh. So 7 timers we have. Is it clear up to this that we have made program for 7 timers first? Is it clear? It's very easy. Tell me, is it clear? See, timer program, I'm talking about timer program only. I shall come to the output program. First, I have made program for timer. Is it clear? It's
Yeah,
very,
it is clear. It is clear.
it is simple. Just one by one timer has been running. Output I have not taken here because we have multiple output. If we have one output put for each time, then we could have taken output coil simultaneously. But output we have many, so I have kept it separate. So timer program is done, and you can see T6 last timer has broken first timer. What does it mean? It will repeat the process. Fine. Now I come to this again. Here you see how I made this program. I shall tell you. See what I did. After that, I have taken one output. Suppose this one. Listen, look at the screen. How I made program for output. I went to Q0. I have taken Q0, like through table program I made this. So I have gone to Q0. Now you tell me, see this only, see this only. For Q0, you see here. It is started here. See, when Q0 is on, that time, which signal do we have? When we press start button, M0 comes. When we press start button, M0 comes, and immediately your motor should start in forward direction, correct? So as we press start button, M0 comes. After M0, okay, here you see I have taken M1, M2, M3, M4, M5, M6. Why? Because this is for codices I have made. In Mitsubishi, it would be M0, then T0, then T1, correct? No, the done bit of timer. Then T2, T3, T4, T5, and T6 will repeat the process. So you can see here simply, don't be confused. I am just seeing Q0, don't see other output please, only Q0. When does it get high? Q0. Q0 gets high here when M0 is high. So I am taking here M0. M0 is high, Q0 will be on. You see, immediately after that Q0 is off. So when it is off, T0 is there, correct? When Q0 gets off here, T0 is there. So T0 NC, because it is making it off. So T0 NC after that. Now, again it is on, you see Q0, only Q0 you see. Again Q0 is on. When it is on again, what is the signal? T1, next timer. So T1 will make it on. For on you have to take NO in parallel. Correct? Next. It is on simultaneous, consecutive on you have to skip. Consecutive on you have to skip because once T1 is on will be continue on. No need to take T2 also in parallel. Okay, these two have been done. Now you see it is off here. When it is off, what is the signal? T3. So T3 is going to make it off. T3. Next, what is that? This is consecutive, you leave. Then again it is on when we have T5. So when it is on, you have to take in parallel. You see, you have to take your parallel outside of this NC, not before that. So it is your T. So it would be T5. So your Q0 is done. Tell me, is it clear? Please tell me, is it clear? For your means to understand more, I shall make one more output. It would be more clear. But up to this, is it clear?
Sir, can you explain this again?
Then I shall make one more output I shall make. It would be clear. You have not understood. Okay, no problem.
So why is that T5 taken separately?
T5, you see here, from T3 and T4, it is off, correct? From T3, T4, it is off. After that, it has to get on also. Again, it is getting on. After this off, this Q0 is getting on again. So T5 is there. So T5 will make it on from outside. Like up to this, it is broken. No, up to this, it is broken. As T3 has come, it has broken the path. So I can't take here. So if I have to make it on again from T5, then separately I will have to give signal here so that this signal can reach to Q0.
Okay, sir.
See, one question I had skipped. You have asked AC drive can increase frequency as well, but how in India we can have 400? See, that 50 hertz we have ideal hertz for any device, like for any home appliance or for any appliance in India, we have 50 hertz operation. So we have 50 hertz generally. But when you design a motor of suppose 400 hertz, then that AC drive will increase that frequency inside it. It's not like it will increase hertz of your home or also or for all appliances. For that motor, AC drive will do the things inside it, and it will increase that to 400 and will give to motor. So it can be increased. It's not like if we have 50 hertz maximum, then it cannot be increased. It can be increased. See, it was increased, then only we have 60 hertz outside. Okay. Anything? Okay, done. No question. So once more, I shall make program for this output and it would be clear, you see. This time, concentrate. Again, I have to, we should concentrate on Q1 only. Don't see Q0 or Q2, just Q1. And you people have to answer, huh? Some people have to answer me. Now I'm making program for Q1. Tell me, when does it get start? It is off. Initially it is off, leave it. It starts here. When it is started, which signal do we have? Tell me.
I0.
T0 actually. It is T0
T0.
here.
T0.
Ah. So it is started by T0. See, you will say it is 0, so can't we take NC of M0? There is no use. Don't take. Start from start only. So T0 will start this. I'm taking T0. Then here it is off. So when it is off, what is the signal?
T1 NC. NC.
T1.
T1.
T1 NC, correct. And you see, we have T2 also to stop, but no need to take because
Leave it.
T1 will be break high, leave it. If you take here, no issue, but it will increase the steps. So leave it. Consecutive, you leave. Now it is on. What is the signal?
T3 and no op
Three
panel.
separately and
Yes. T3NO. Correct. Very good. So you have to take after this because it has been breaking this path. If you will take here, it won't go to Q0. So it should be from outside. Consecutive, you leave. And finally, it is off. So for off, what is the signal? T5. Break this. Your Q1 is done. Yes. Fine. So I this program, I have already made this here. You see, already made this here. So what you people do, uh, this project also you can mention in your resume. So this is multi-speed control of an induction motor using VFD controlled by PLC. In this project, AC drive name I have told you yesterday. PLC name you write down. I have changed the PLC. This time I have taken FX1S. Write down the PLC name. PLC name is FX1S 20 MT. 20 MT. T inputs outputs we have transistor type. 20 MT. Done. Fine. Now I shall send this to. Actually, I have already sent. You know the process of sending program. You have to check the last ladder. We have 58 steps. We can go to online, can go to write to PLC and can send it. No need to send because already we are running late. So I have already downloaded. After download, how will it run? That let me show you using one video. I have made already. Today I have made video already. Let me show you. A VFD video here. So as we press start push button, it will start in first speed, and direction also you can see. Here you see it is running in first speed. This is the PLC FX1S. This is the drive and motor direction change you see. Second speed, this is second speed. Third speed, fourth speed, fifth speed, sixth speed, seventh speed, last speed actually. And this is repeating the process. Now it is 50 hertz again. So you got this? So your direction will change, duration you have set in program already. And as per the combination of that RL, RM, RH, it has been running. Forward, reverse, RL, RM, RH. So here you see from AC drive, these wires have come. So from digital terminal, I have brought the wire and have connected to output of PLC. That side is output terminal, like you have input terminals here. We have output terminals there, and there we have just connected it. That is it. Okay. So this project also you can keep with it. You can mention in resume if you want. Fine. So we did one project. Next is AC analog. See, analog practical thing I won't be able to show you today in this training program, but I shall tell you how do we make program. We all together make a program. Because RPS and all I had to arrange, but I could not arrange it. If I had RPS, then 0 to 10 volt I could have given to ADC, and you could have seen the data on SCADA. But programming, I shall tell you how do we make program for analog in industry. Anything else? Nothing. So this program, see, in SCADA we can display this also. AC drive thing we can display in SCADA. This I have made with Codesis. So in Codesis I have displayed speed, hertz, speed number and hertz. Running time also I have displayed. Start, stop. And this is the wiring you see. This is the wiring. STF is forward, STR reverse, RL, RM, RH. So from PLC, and this is the common of AC drive. So PLC common will go to AC drive common, and there is no SMPS you see here. It does not need SMPS. It just needs to be short. And you know when PLC output is on, it is short, correct? So here it will get short. If you have to run in forward, it's common, AC drive common, and STF you make short through one wire, it will run in forward. So these two will make it short. So direct connection you have to do. There is no any voltage required here. Simple wiring. Then from AC drive you can see RYB I have given to motor. RYB I have given to motor. That is the simple wiring. The same program, you know, can be done using that word address also. So I have made, see, this is I told you. There are many applications. I shall go to analog. So here you see QB0 I have taken. There is no output coil. I have moved value for different output combination. We have different decimal value here. Calculated, I calculated, and these values I have moved to QB0. I have not taken QW0, but QB0. Because if you take QW0, then Q0 to Q15 will be used. And you won't be able to use that in coil again. So you have only 5 outputs. So better you go with byte only. Or else after 8 also, your terminals will be used. So either you make like I have shown you just now, or you can make using move instruction by word address. Analog input output. Yet we have gone through digital signal where we had two states, correct? On and off. In industry, in industry, you will have to work on analog input output too. It is sure. You have to work on analog input output signal also. More inputs outputs will be digital, but analog input outputs will also be there. And mostly in process industries, food industry, pharmaceutical, we have lot many analog signal. Now you see, analog signal does not have just two states. Analog signal will not have two states only, but it has variable signal like 0 to 5 volts, 0 to 10 volts, 0 to 20 milliampere, 4 to 20 milliampere. So you can see it is varying. It's not fixed 0 or 1. So it is varying. It will be sometimes 2 volt, 1 volt, 3 volt, 4 volt, like that. Okay, fine. So when we have application where we have analog input like temperature, no need to look at the screen, you just listen to me. When we have application where we have analog input like temperature, pressure, flow, displacement, correct? Level of the tank, or luminous intensity, light intensity, there we have to use analog transmitter, and we will have to make analog program. When we have analog output, so these we had discussion about analog input. When you have temperature, pressure, flow, level, displacement, when you have analog input signal, you have to write program for analog input, and ADC will be used. When you have analog output like control valve, vibrator, or motor speed controller like VFD, just now I have given you example that we can use AC drive as analog input output also. Okay, fine. There we will use analog program again for analog output. Analog input like temperature, pressure, flow, level, displacement, luminous intensity, etc. are not electrical phenomena, correct? It's not electrical phenomena. First, it needs to be converted to electrical energy. See, anything, if you are able to convert that in electricity, or you can generate electricity against that, you will be able to control that, correct? You will be able to control that. In medical science also you have seen pulse, heartbeat, other things. It has also been converted, or you can say electricity has been generated against this, and it is being controlled. So first it needs to be converted to electrical energy. If we are able to convert non-electrical thing to electricity by any mean, then we will be able to control it. The device used to convert one form of energy to another form of energy is called transducer. You people are very much familiar with this, and again, its internal operation you people know more than me. So academicians are more expert in its internal operation. So here transducer will be used, correct? Okay, fine. There are different types of transducer available depending on the method used to convert one form of energy to another form, correct? We have different type. Fine. There are different types of transducer available. So here we have two terms, analog sensor and transducer, correct? Analog sensor and transducer, and be very sure that in interview your faculty or you are working in industry or you are engineering student, in interview one common question is, what is the difference between sensor and transducer? What is the difference between sensor and transducer? Can anyone tell me? What is the difference between sensor and transducer? We have student from instrumentation also. Anyone?
So in a transducer, the output can be of any form, whereas in sensor, irrespective of the input, the output is always an electric signal.
Okay, fine, correct. And there is one common answer also for this. You are exact. You are correct actually. A transducer can be a sensor, but sensor cannot be a transducer. This is simply you will find in book and all, and people will talk like that. A transducer can be a sensor, means transducer can be connected to field directly. But a sensor cannot convert always. A transducer can sense and can convert also, like LVDT. But a sensor can sense, sensor cannot convert that into another form. Okay. To work easily on analog system in industry, industrial automation, let us go through block diagram. And believe me, these block diagrams will make the things very easy to work on analog system in industry. See the block diagram for analog input, not output, analog input. So first, let me take this to MS Paint. There we shall have a note and we will have more discussion. So these blocks will help you to work on analog system, analog input system in industry. Very first, we have sensor or transducer, correct? Very first, we have sensor and or transducer, which will be connected to the field. Now, sensor, not sensor, but transducer. Transducer will generate electrical signal. So you will have a very small amount of voltage, correct? It will be very small, millivolt. It will be in millivolt. So that will be amplified first. So that millivoltage will be amplified. After amplification, it will be sent to transmitter. This is the important part. Nowadays, we don't have all these things separate. When you go for temperature transmitter, all three things will be one assembly, will be in one assembly. So we purchase directly temperature transmitter, flow transmitter, level transmitter. So all these three things will be a single unit nowadays. So after amplification, that signal, amplified signal, will be sent to transmitter. Transmitter, what is this transmitter actually? Transmitter will convert any signal to one standard signal, correct? In electronic communication also you have transmitter where you impose the signal on some standard signal and you transmit like that. This transmitter will convert that amplified signal into some standard signal, and that standard signal will be sent to the converter. And what would be the converter here? The converter will be ADC, analog to digital converter. ADC, analog to digital converter. And then that converter will be connected to the controller, that is your PLC, your Arduino, your you can say any electronic device, or it can be connected to PID also. So we have one controller, ours is PLC. Now you see we have this transducer transmitter, and I told that transmitter will convert one signal into standard signal. So what would be that standard signal? That signal we can have in terms of voltage or current, correct? That signal we shall have in terms of voltage or current. So voltage or current. Tell me, which signal is better? Voltage signal is better or current signal is better? Answer me fast because we are running late. Today we will have to extend the session. So which signal is better? Tell me, voltage signal or current signal? Voltage signal. Why voltage signal? Scholars, tell me, which signal will be better? Voltage can be measured easily without interruption. On audio, you people, Google Meet people, which signal is better? Okay, then I shall tell.
Sir, voltage.
Current signal will be better. No voltage, current.
I think
Why I shall tell you.
voltage is subject to losses, particularly at lower voltage.
Yes. Yeah, no, you see, you're correct. See, when we take voltage signal, you see your tank can be away from PLC. Obviously, it would be away, far away from PLC control panel. So one wire will come from transmitter to your control panel, PLC panel. So wire you have long distance wire. So what will happen? Or let it be short distance also. When we have wire, we have resistance, we have voltage drop. It is sure. When we have high long distance, then obviously we have voltage drop there. So signal on transducer point, transmitter point, and signal on ADC point can vary. We can have signal loss there. So voltage we don't prefer in when we have long distance. Current, you know that on each point current will be the same. So current signal is preferred. So voltage and current, we have two standard. If we have voltage, I had mentioned in PDF also, it can be 0 to 5, it can be minus 10 to plus 10. Generally, we use 0 to 10 volt standard. But we can have different standard also. Now, if we have current, I told it can be 0 to 20 milliampere. And as 4 to 20 milliampere also. And 4 to 20 milliampere is preferred. Why is it preferred? That is also a question. We shall have discussion about this later, you remind me. So you understood that transmitter will convert signal into standard signal, voltage and current. And current is better. Voltage also we use. It's not like we don't use. But for long distance, current will be better. And in current also 4 to 20 milliampere will be preferred. Next, it goes to ADC. Now ADC, what do we have on ADC? For ADC, I will show you that in, I told you about this. Now here you see, this is your ADC. See this. See this. In ADC, you will have different channel. I will tell you, in industry we call it input module, analog input module, or analog input card also we call it, analog input card. So we purchase analog input card as per our requirement. Like if we have two sensors, then 2AD card, 2AD, analog to digital converter card, 2AD card, 4AD card, 8AD card, it will come like that. So this is a 4AD module or card, analog input module, ADC. 4 AD card means it will have 4 channels. 1, 2, 3, 4. Channel number 1, channel number 2, 3, 4. Each channel will have minimum 3 terminals. You can see everywhere you have 3 terminals. So you can see in each terminal, in each channel, what do we have? In each channel, what do we have? We have voltage, we have current, and we have common. So we have 3 terminals. One is for voltage, one is for current, one is for common. So here it is V1, I1, C1, V2, I2, C2, V3, I3, C3, V4, I4, C4. So suppose I have to connect transmitter here. We have 2 transmitters. One transmitter will give us voltage standard signal, and another transmitter will give us current signal. So you can see from transmitter 2 wires will come. One will go to voltage terminal and another will go to common. If it is current standard, then one wire will go to current and another will go to common. That is it. So this is your ADC, analog to digital converter. In industry, it will look like this somewhat. And this is a bus connector. It will be connected to your PLC, to the extension port. Like this, it is connected. I have brought ADC. I'll show you. Okay. So this you understand. We have ADC. After that, you have controller. You see, controller. We have PLC here. Fine. Here you see one application we have taken, one example we have taken. But before that, we should see analog output also. You can see in analog output, this is important to discuss. We need to discuss this. Analog input, you understood. Analog output also, let us understand. For analog output, I have given here HMI SCADA. In any block you won't, in any book and all, you won't find this HMI SCADA. But practically, I think it should be there. Practically, HMI SCADA should be in our block, because without this, analog output is not complete. Why? I shall tell you. In analog input, what happened? In analog input, ADC, what happened? In analog input, voltage came and was converted to digit, correct? In analog input, what we did? Voltage we converted to digit, numerical value 1, 2, 3, 4, digital value. ADC converted voltage to digit, and that digit was taken from PLC, correct? PLC took that digit, then it processed according to requirement. So in ADC converts voltage into digit. DAC will convert digit into voltage, correct? Numerical value, you will give 50, 100, 20, 60. That number should be converted to voltage. So obviously, for your device, suppose control valve, sometimes you want 10% open, sometimes 20% open, sometimes 100% open. So every time you have to change your set point. So if you have to change your set point, then obviously you should have interfacing device, or else how will you change as per your requirement? So HMI or SCADA must be there when you have analog output, because it's not like that one value only you have to move to control valve. You have to send your different, you have to send variable value. You have to change the preset all the time. 10% open, 20% open, 30% open, you have to change. And as you have to change, HMI SCADA is a must. You have to connect. So in that block, I have given HMI SCADA. It will send digit to PLC, correct? Suppose I have in HMI I have given D0. In D0 I give some digital value. I enter some value like we entered for timer yesterday. Suppose I enter 50. This 50 will go to PLC, correct? It will go to PLC. Now PLC will send this 50 to DAC. Now what DAC will do? DAC will convert that into 5 volt DC and will give to control valve, analog output. Is it clear? So digit will be converted into voltage by DAC. So this is your block, 4 blocks: HMI SCADA, controller, converter, DAC, and then analog output. Analog output, I told, it can be vibrator, control valve, AC drive, any output, analog output. Here again, you have the same channel. Now this is called DAC, we call it DA card, DA module. Like it was 2AD, now it is 2DA, 4DA, 8DA, like that. Fine. So analog input, analog output, we understood. Now we have taken one example here. And you know, I have taken a difficult, I have selected difficult module. Why? If you understand difficult thing, easy thing, obviously it is easy. You will understand that easily. Mitsubishi, new Mitsubishi program is very easy. They have provided very easy things. But when we have used this Mitsubishi FX2N, we have used 1S. In 3U, 5U, it's easy. Analog programming is easy. But before that series, it's very difficult. You go for Siemens, Allen Bradley, all the Allen Bradley has also bit complication. But in all new PLCs, in all brand new PLCs, they have made user-defined things. So now it is easy. But everywhere we have some steps to be followed, and without user manual, it is impossible to work on this because they have their rule for different module. For Mitsubishi, there are many modules, 2AD, 4AD. As module will change, rules will change. It's not like you will have fixed rule for all modules. In Allen Bradley also, if you go for different module, and one thing, if I have Mitsubishi PLC, I have to use Mitsubishi ADC DAC only. No other brand will be connected. So same brand ADC DAC you will have to use with PLC. No any other brand. Okay. So how they have made the things easy, I shall tell you the easy things. Then I shall try to make you understand this difficult one. Because in old machines, obviously you will have this thing only, the difficult one. If I tell you about the easy thing, what they have done, they have defined it already. Like in Siemens, it is AIW0, suppose. It is same as like it was IW0. IW0 is for digital input. This is for analog input. So AIW0, then AIW2, it will be of double word always. This is of double word. So 0, 1, both will be included in the same. Now 2 and 3 will be included. So AIW4, it will be there. So they have defined, like if they have 4 channels, suppose, 4 channels, I have shown here, okay, let me make it 4 channels. If you have 4 channels, then they have already defined that channel number 1 converted value will go here itself. So you just connect the things, you have to do nothing. In your program, directly you can use AIW. So already converted value will be available here. Here, for channel 2, already converted value is available. For channel 3 and 4, all will be available itself. So you don't need to write a big logic for this to get the converted value. But when you go to old version of PLC, not very old, You will have to make program to select the channel. You will have to make program to select voltage or current. You will have to make program to start conversion. You will have to select. You will have to make program to take that converted value from memory. So all these things we need to do, but nowadays they are giving the things like this. They have already defined the things, and you can take the converted value directly. Let me give a try to make the things understand to you people. Keep patience, keep patience, but I have doubt. Let us see. Okay, see this. This is for Mitsubishi only. This instruction, these instructions we have for Mitsubishi, not for other brands. So what we have here actually, TO, this is TO2. See, you will understand. If you will follow me and will answer, you will understand this also. This is not that difficult. But if you go to its user manual, it's very difficult to understand. Application first you see. The application is you have a PLC, and to this PLC you have connected many modules. You have connected many analog or other modules also. So by default, this is your 0 number module, this is your 1 number module, 2 number module, like that. These are extensions. Suppose this is our ADC or DAC. This is our AD or DA module, suppose. First one is our DA module. Then you have two instruction, TO. Two instruction, this is one example actually. This is one example. T0, K17, K4, K1, this is one example. So in this example, in this instruction, you have 1, 2, 3, 4. Four things you have to mention. In two instruction, and in from instruction, you have to mention four things. First thing you see, K0. This is one example. What is this location for? What we give on this location, what we feed in this instruction. This is for module position. This is for module position, means where have you connected your module to your PLC. Got this? So here I need to mention, okay, my module is 0 number. So I have written K0. Is it clear? So here you see, I have connected ADC module to 0 number. So I have given here K0. If I have to take signal from this, then it would be K2. Okay, fine. Once more. Two instruction we use when PLC has to send something to module. Got it? When PLC has to send command to any module extension, then two instruction will be used. Now, when you use two, you understand, okay, PLC is saying something, sending something, writing something. But where it is sending to module number 0, for example. Now, to that module, to this module, we have some memory also, correct? We have some memory inside that. We call it buffer memory. So this is your memory, module memory number of module. So up to now you see, up to this you see, PLC is sending something to memory number 17. Clear? Listen carefully. You will understand. It's not difficult. PLC is sending something to memory number 17. Of which module? Module number 0. So PLC is sending something to module memory number 17 of this module. Now next, what is this? This is the value, some digital value or binary value, some value, numerical value you are sending to the memory. So value to be sent to module memory. Now we shall read up to this. PLC is sending value 4, decimal value 4, K4 means decimal 4. PLC is sending 4, number 4, value, numerical value 4. Where it is sending? It is sending to memory number 17 of module 0. Clear? Next, K1. But before K1, you tell me, is it clear up to this? PLC is sending value 4, this is example only, it can be changed, value 4 to 17 number memory of module 0. Is it clear up to this? Tell me, is it clear till now? Not clear. See, at least let us understand the instruction. Leave program. But at least you try to understand the instruction. After that, I shall stop. Don't worry. Tell me, this 2 instruction up to K4, it is clear or not? If it is not clear, you say no.
No, to me, I just have a doubt, particularly with respect to K17. I think K0, the 0 is the position driven, where the module is there, that number comes.
Yes,
And
yes.
K4, it is our input driven. Whatever we wanted to place, we place that value. What is this 17? 17 is driven by which?
See, 17 is actually memory number. Like you can say memory number 1, memory number 2, memory number 3, memory location you can say. This is the memory of that module. In ADC, if you will send something to ADC, that thing should be stored somewhere inside ADC. So ADC will have some memory where it can store something, correct? So that 17 number is the memory location of ADC. Is it clear?
Yes. And
Yes.
what does it convert to? Like, word, bit that we were discussing previously. Similarly, what
Convert,
is
you
this?
see, we are not converting. I am talking about instruction only. Because PLC has to send command, correct? To module, ADC module.
Yes.
PLC has to receive something from module. So
Yes.
first you will have to make program that PLC is requesting something, 2 instruction will be used. PLC is asking something. PLC is sending something, 2 instruction will be used. PLC wants something, from instruction will be used. So first you need to understand the instruction. Then we will come to the conversion part.
That is clear. Till that it
Clear.
is clear.
So PLC is sending the value 4 to memory number 17 of module 0. Now this K1 you see, it is called bit length. Bit length. Actually, what is this? This is number of consecutive memory of module. Number of consecutive memory of module. I shall make it clear. Suppose in this example, PLC is sending 4 to 17 number memory of module. Suppose PLC wants to send 4 to 17 number, 18 number, and in 19 number consecutive memory location. Same value, if you have to send to consecutive memory, then directly you can write here K3. So 4 will be sent to 3 consecutive memory. That is it, nothing else. So as we are sending 4 to only 17 number memory, I have given K1. Is it clear? Is 2 instruction clear? Tell me, everyone. Is
Yes,
2
sir.
instruction clear?
Yes, sir.
Okay, okay. If it is not clear, then also you will say yes because we are running late. You are getting
Yes, sir.
hungry, I think.
Yes, sir. Yes.
Yes, sir means you are getting hungry.
No, sir.
Okay, so you understood it. Now you say, 2 instruction is clear that PLC is sending some value to memory of module number 0, and that is sending to one memory only. Now from, you see, from instruction. From instruction is used when PLC wants to receive something from module. So anything, if you want from module, you have to use from. Now you see, from module number 0, again from module number 0, memory number 13. And this is your PLC memory. Now I shall tell you what is this. PLC is reading or receiving. PLC is receiving something from memory number 13 of module 0. See, this is, for example, this can get changed also. PLC is receiving something from memory number 13 of module 0, and after receiving that, it stores in D0 of PLC. It can be D1, D2, any. Got it? PLC receives something from 13 number memory of module 0 and stores to D0. And stores to D0. Is it clear? Is it clear?
Yes, sir.
Very good. So you people tell me, are you people interested to learn its programming, or shall I stop? Because its programming will again take, to understand it will take, I think, 15-20 minutes minimum. Shall I proceed?
Sure, sir.
Yes, sir. Maybe after break.
Maybe after break you want this, but you know, after break I cannot continue this because after lunch I have to finish that IoT application, and we have validatory function also at 3 o'clock. So only IoT I will be able to finish after lunch. Okay, what I say, people interested to go for lunch can go, and if some people wants to stay, tell me, I shall stay for them. If it is like that, some people you can text me. If you want to stay, I shall stay and will clear this.
Sure, sir.
Okay. Then I shall continue, and people who wants to go for lunch can go also. So
Hello, sir.
Mhm.
I was asking about that K1 for from module. Like, you didn't, how it will work?
That last K1, no, that is again bit length. Like you want to store that in one memory, or you want to store in consecutive memory. Okay, so I wanted to store that in D0 only, so I have given there 1, K1. Okay, now you see. Here, look at the screen, please, and mute, please, mute. Look at the screen, and now we come to the main part, the rules. See, this is for particular module. I shall show you the module. See, this is the module. After explaining this, after explanation, I shall show you on full screen also. This is the module. It is, the name you can write down, it is FX0N3A. FX0N, FX0N3A module. And this is a combo module. Combo module means it has analog input, analog output both. It has 2 analog input channels and 1 analog output channel. 1 analog output channel. Got it? So on this module, we have two analog input, one analog output channel here. Fine, let it be. It takes power supply from PLC itself, but many modules will require 24-volt DC to get power on. Many modules will require 24-volt DC to get power on. And here you can see we have the bus which we connect to PLC extension port. Okay, let it be. Now you see the rules. Rule is, for any analog module, few things you need to search in user manual. First thing you need to search is channel selection. Channel selection. What is this channel selection? Channel selection means, as I told, we have two channels here. So we can connect two analog transmitters. Now, while making program, you will have to mention from which channel you want converted value, from which signal you want the value. So you need to select the channel. If you have 4 channel, then you need to select which channel you want, for which channel you are making program. Correct? So channel selection is first requirement. Second thing is AD, analog to digital conversion start. Analog to digital conversion start. And third is DA start. Digital to analog conversion start. Actually, what happens? As you have connected transmitter to channel terminal, so signal will come to channel, but it will not convert that into digit, or it will not convert that into analog. You need to send command, okay, now start conversion, then it will start converting, and then you can work with this. So nowadays it is by default set, but mostly it is like that. You have to select the channel. Now for channel selection, AD start, DA start rule is different in different PLC. Here let us see for this module what they have said. They have told that for channel selection you can use buffer memory number 17, means 17 number memory location you can use for channel selection. Concentrate. 17 number memory will have bit on this. 17 number memory will have bit on this. If it is 8 bit, then 8 bits, or if it is 16 bit, then 16 bits. So this is your 17 number memory. It has bit number 0, bit number 1, bit number 2, like that. Now for channel selection, the rule is bit number 0 is for channel selection. See this one. Bit number 0 is for channel selection. In bit number 0, if you send the value 0 in bit number 0 of 17 number memory, if you send 0, then channel 1 will be selected. So by default channel 1 is selected because already it will have 0. Got this? If you want to select channel number 1, then it should be 1. It should not be 0. It should be 1. Got it? If you want to take signal from channel number 2, then B0 should become 1. Okay, done. So channel selection, tell me, people who have been attending and are serious about this, answer me. Did you understand channel selection, or shall I tell this again?
Understood, sir.
Okay. So when bit number 0 will be 0, channel 1 will be selected. When bit number 0 becomes 1, channel 2 will be selected. Now, bit number one, what is this for? Bit number one. It says in bit number one, in first ladder, you send 0, and in next ladder, you send 1. Got this? In memory number 17, bit number 0, bit number 1, in that first you send 0, and in next ladder you send 1. So it will be 0 to 1. As bit number 1 becomes 0 to 1 in scan, AD will start. AD conversion will start. And in bit number 2, if you make first ladder you make 1 and second ladder you make 0, then it will be DA start. This is the rule, we cannot change it. Once more, in 17 number memory, which is suppose of 16 bits, one word. So this is one word memory, 17 number. In this memory, we have bits. 3 bits they have given for read and write. Others are reserved. You cannot change anything here. So in bit number 0, if you write 0, it will be channel 1. In bit number 0, if you write 1, it will be channel 2. In bit number 1, if you write 0 and in next ladder you make it 1, then it would be AD start. Bit number 2, if you write 1 in first ladder and in second ladder in the same memory you send 0, it will be DA start. So this is memory number 17. It will start conversion and it will select your channel 2. Channel will also selected, will also be selected. Now you see, channel is selected and conversion has been started. Now that converted digit from voltage, digit has been converted. That converted digit will be stored in some memory location again, correct? No, if ADC converts voltage to digit, that digit will be stored somewhere in this module in some memory location. So that current value of output data channel stored in 8 bit. Current value of input data is stored in 8 bit AD channel. Okay, so that is stored in memory number 0. When analog was converted into digit, that digit is stored in 0 number memory, BFM number 0. So from 0 number memory, you can receive the converted digit. Got this. Now, one more task is there. You have to send digit to DAC, and DAC will convert that into voltage. So when PLC will send some digit to DAC, PLC will send that digit to some memory location of that DAC, correct? You will have to send that digit to some memory location of DAC. That memory they have given 16 number. So whatever digit you send to 16 number memory of DAC, that will be converted into voltage. That is clear? Whatever value digit you send to 16 number memory of DAC, that will be converted into voltage. So this is AD converted value. This is DA conversion value. So 0 number memory will give you the converted value. And when you send some value to 16 number, it will be converted to voltage. That is it. Now, I shall make one program for example, and then I shall stop it. Program I will show you on screen only, will not make in software. You see, our requirement you understand now. Requirement I have given, channel number 2 should be selected, AD should start, DA should start, and receive converted value from memory number 0. So I am like writing BFM 0, receive value from BFM 0. And for analog output, send value to BFM number 16. So first we shall do this thing. all participants look at the screen and answer. First, we shall make program for channel number 2 selection, AD start, DA start. You know that it will be done by 17 number memory. So tell me, what is the rule to select channel number 2? Tell me, what is the rule for this module? What is the rule to select channel number 2?
B0 should be 1.
B0 should be 1. Very good. So I am making this for 2 ladders because 2 ladders will be used. So it should be 1. So in first and second both ladder it should be 1. Okay. For AD start, what is the rule? For AD start, what is the rule?
B1 goes for 0 to 1.
0 to 1. B1 0 to 1.
And this will be
1 to 0.
1 to 0 for DA. You see, here only you will understand how to make program. This you have taken for ladder number 1. This you have taken for ladder number 2. Next ladder. For ladder number 1, what is the binary value? 101. What is the decimal of 101? 1, 2, 4, 4 and 5, correct? What is the decimal of 101? What is the decimal value of 101? 4 plus 1. 5, correct?
5.
Yes. Now, what is the decimal value for this? 1, 1, 2 plus 1, 3. So it is 0, 1, 1. So it is clear that in first ladder, in 17 number memory, I have to send 5. In second ladder, in 17 number memory, I have to send 3. Is it clear? Is it clear?
Yes, sir.
So you see, I shall make ladder for this. 2 instruction will be used, correct? No, because PLC is sending command to module. So tell me, I take here 2 instruction. Module number is 0, so K0. After this, what should I take? After this, what should I take? To which memory we have to send?
BFM 0.
I am I have to send this command. To which memory I have to send this command? For channel selection and for channel selection
0.
and for ADD start, which memory has been used? Here is the memory 17.
17.
Yes, yes, you see.
17.
17. So you see, this is your first ladder. To 17 number BFM, you have to send 5 first. 101 is 5. So decimal is K and 5 and K1. This is your first ladder. Next, the same thing. Module number 0, memory will be the same, but this time you have to send 3. And you see, is it clear? These 2 ladders you made for channel section and ADDA start. Is it clear or any doubt? Tell me. I hope it is
Yes,
clear.
sir.
Clear. Now I have to receive. See, from channel 2, we have selected channel 2. Conversion has been started. So digit has been converted and is stored in BFM 0. So I have to receive converted value from BFM 0. What should be the instruction?
Analog to digital.
I have to receive something from BFM 0, means memory number 0, to receive which instruction will be used. To or from?
From.
From will be used. So I take here from. So I want it from module 0, and you have seen that memory number 0. So I will take K0 and K0. Don't be confused. this 0 is module number, this is memory number where we have converted digit. And after receiving it, I shall store that in some PLC memory, that is D0 or D1, whatever you have taken. So I take D0 here. So here is D0 and K1. Up to this, what we have done, selected channel number 1, AD start, DA start, from these two. Third is converted digit from 0 I have taken to D0. And this D0 I can give to HMI SCADA. You can see there temperature and other things. Okay, now one more thing. To control valve, I have to give voltage. So digit I have to send to 16 number BFM. Digit I have to send to 16 number BFM. It will be converted into voltage. So as I have to send, which instruction we have to use? To instruction. To module number 0 and which memory? 16 number memory. From where? From PLC. So suppose in PLC I have taken D2. We can take any memory. And this D2 I have given to HMI. So from HMI, we will see the value in D2. It will go to PLC, and this PLC will send this to 16 number of analog. And analog will send it to control valve. So your program is ready. So this is your program. You can take the screenshot and we'll stop now. You can take the screenshot and we'll stop. So 1 o'clock, we assemble, and see that IoT, I'm sure that many participants have already made experiments on IoT. So might be the experiment I will show you will be the same what you have done. But I know that many people have not done. So for that, one simple application I have selected, and I request if any overseas participant is attending the session today after lunch, please text me. I want you people to operate machine from your place. Okay, so we will do this after lunch. Thank you very much for your patience. Come at 1 o'clock, please. Thanks.
Excuse me, sir. Hello, sir. Yes, sir.
Tell me.
Sir, would you like to brief out about the instructions of the exam?
Okay, yes. Listen, participants, we have one examination today. Might be, I think 30 questions will be asked objective. 50% marks will be compulsory to get certificate, and it is compulsory because certificate we won't give to any participant. If you have attended seriously, you get certificate. And I know many people are here, maximum people are here attended. Questions will not be difficult. Questions have been given from the topics we have covered here, and that will be in your notebook if you have noted down. Questions will be very easy, objective. 50% marks will be required for certificate. So attendance, that examination, 50% marks. I think these two only. These two will be compulsory. Thank you very much. We'll see you at 1 o'clock.
Hello, sir. Can you please repeat that project title, that multi-speed control?
Multi-speed control of induction motor using AC drive controlled by PLC. Using AC drive controlled by PLC, and if you add SCADA in this, one term will be added, monitored on SCADA. So AC drive, multi-speed control of induction motor using AC drive controlled by PLC, but SCADA we didn't do, so don't add. Okay, shall I leave?
Yes, sir.
Thank you. Bye.
Bye, sir.